Let's take this algebra review worksheet here. Our first problem has to do with square root of 44, very simply. So we're going to try to think through what perfect square goes into 44. Well, that's 4 and 11. Perfect square times what's left over, so our answer is 2 square roots of 11. Our next problem coming down is the square root of 27. That's the square root of 9 times the square root of 3. Once again, we're trying to find a perfect square and what's left over. Square root of 9 is 3, so our answer is 3 radical 3. Square root of 80, trying to think what goes in that. Well, I know 4 goes in it, but I also know that 16 goes in it. So 16 times 5, I want to take the largest perfect square that I can. The square root of 16 is 4, so my answer is 4 radical 5. As I move down the page, I have the square root of 50. What goes into the square root of 50? Well, 25 does. 25 and 6, leaving me with 5 root 6. In each case, I'm trying to find the largest perfect square that goes into each problem. 40 is the square root of 4 and the square root of 10, which is 2 root 10. 128. I do know 4 goes into it 32 times, but I also know 4 goes into 32. So as I'm thinking of that, I can quickly deduce that 64 goes into 128 2 times. And the square root of 64 is 8 square roots of 2. So it's important to try to find the largest square root. In that one we could have had 4, 16, or even 64. If we had gone down the route of taking out a 4, we would have been left with 32. Now we would have had to break down the 32. So we would have had 2 times 4, root 2, and gotten 8 root 2. The same answer, but with a couple more steps. Our next problem is the square root of 54. 54, if you think about it, is 6 times 9. So the square root of 9 is 3, and we get 3 root 6. 96 is 8 times 12, but that doesn't help us. If we were to take a 4 out of 96, let's think what would be left. Well, 96, when you break it down, is 2 times 48. 48 is 2 times 24. So, 96 is 4 times 24. Trying to think through this in our heads, 24 breaks down into 4 and 6. So we have 2 times 2 times 6, which is 4 root 6. If we had known that 16 had gone into 96, we could have approached it that way, but you can take a slower route and break it down step by step if that's helpful. Looking at our next column, number 9, as we look at it, is the square root of 45. 45 is 9 times 5, which is 3 radical 5. 50 is 25 times 2, which is 5 radical 2. 8 is 4 times 2, which is 2 radical 2. 200 is 100 times 2, which is 10 radical 2. 24 is 4 times 6, so radical 4 and radical 6, which is 2 radical 6. 52 is 2 times 26, which is 2 times 13. So that's 4 times 13, or 2 radical 13. 18 is the square root of 9 times the square root of 2, so that's 3 radical 2. 125 is 25 times 5, which is 5 radical 5. Moving to our next page, we now move into numbers that are going to start to get larger and might have numbers in front or also variables on the inside. The square root of 75 is 25 times 3. We're still sticking with the perfect squares out front, so that's 5 root 3. 32 is 16 radical 2, so that's 4 radical 2. Now we have a number out front. When we have a number out front, like this 6, we have to consider what we're going to do with that. Well, we're going to drag it down and just carry it along, just like anything else. So this is 6 times 3, or 18. The negative 4 on the next problem is going to also come out front, and then we're going to break down the 24 into root 4 and root 6. The negative 4 comes down, and the 4 comes out as a 2. But we still have the root 6 inside. So our final answer will be negative 8 root 6. We bring down the 8, just like before, and then we're going to break up the 32 into 16 and 2. 8 comes out, square root of 16 is 4, and we're left with radical 2 inside. This leads us to our answer of 32 root 2. The negative 9 comes down, and the square root of 8 is 4 and 2. That leaves us with negative 9 times 2 with the remainder of root 2 inside, giving us a final answer of negative 18 root 2. Number 23, we've got the 5 out front, just like before, but on the inside we're going to have square root of 4 and square root of 5. Square root of 4, as you know, is 2 times the square root of 5 left over. That gives us an answer of 10 root 5. The negative 2 comes down, just like before, and the square root of 16 actually comes out as a 4. That gives us an answer of negative 8. The 2 is carried along, and the 12 is broken down into a 4 and a 3. Square root of 4 is 2. Square root of 3 comes along, leaving us an answer of 4 root 3. The negative 3 comes down, and the square root of 4 is just 2, which gives us an answer of negative 8. Our final column is going to focus on problems that also not only have numbers in them, but also have variables. Our first problem, we have 7 times 18. So 18 is 9 and 2, just like before. So that's 7 times 3, root 2, which leads us to 21 root 2. Now we get to some problems that now allow us to break it into a perfect square and what's left over. Remember, with variables, we want to take out even problems as we're working through these in terms of our exponents for our variables. So we're going to get 4x to the 4th with 1x left inside. That's going to leave us an answer of 2x squared, square root of x. On number 29, we're going to break that down into a perfect square and what's left over. 16y to the 8th. Now, 8 is not a perfect square, but what you do need to realize is 8 is an even number. Our leftover is 1y. So, the square root of 16 is 4. Half of y to the 8th is y to the 4th, and then the square root of y is left over. With number 30, we've got x to the 16th all by itself. So we're going to break that down into an even exponent just below 13. So below 13 is 12, so x to the 12th. 1x is left over, x to the 1st. In the same way, this was y to the 1st up there. Half of x to the 12th is x to the 6th, with a leftover x on the inside. Perfect square, what's left over? Perfect square that goes into 12 is 4. Left over is 3. Directly underneath x cubed is x squared. Left over is x to the 1. Y to the 8th is already an even number, so that'll stay inside. That gives us 2. Cut the x squared in half. Cut the y to the 8th in half. Our leftover, root 3x. Break down the 27. into 9 and 3. X to the 9th breaks down to x to the 8th and even, and x to the 1st. Y to the 3rd breaks down into y squared and y. That leaves us with 3 x to the 4th y times the square root of 3xy. Notice half of 2 is 1, half of 8 is 4. 50 breaks down into 25 and 2. X cubed is x squared and x. Y cubed is y squared and y. That gives us 5xy on the outside and 2xy on the inside of the radical. 32 breaks down into 16 and 2. X to the 5th is x to the 4th and x. Y squared and y. So we have 4x squared y root 2xy. 56 breaks down into 7 times 8, but neither of those is a perfect square. So we're going to go with 4 and 14. X to the 9th is x to the 8th and x. So that's 2x to the 4th root 14x. Our last one is 18. That breaks down into 9 and 2. X to the 6th and x. Y to the 4th and y. So 3x cubed y squared square root of 2xy. I hope these sample problems have been a good example for you to kind of walk your way through a review of simplifying radicals.